Good afternoon, students. So today's topic is set and relation, where which includes both first year as well as second year. So in first year also you studied about set and relation. In second year also you studied about relations, that is what are different types of relation. Yes, good afternoon, Gundarao. So we'll discuss an example related to both first year as well as second year. In second year, you said about in relation is what is a relation and what are different types of relation. But in first year, just basic about set and relation. So students, already we have a lot of time for preparation of the exam, because you all are aware about what is the exam date. So your JW mains exam date is from July 19 to 23, and NEET exam is on 26, and your KCT is on July 30 and 31st. Right, so put your 100% efforts, and so that you can score good marks in your upcoming exams. Right, so just we'll discuss about what all you learned about set and relation. After that, some any standard result related to this chapter, and we'll discuss some example related to this chapter. So as the first, you all aware about definition of a set. It is a well-defined and distinct collection of object, we can tell. It is a well-defined set, is a well-defined and it is distinct collection of object. Distinct collection of object. And what objects are collecting or members of the set is to be the element of a set. And you study about how to represent a set. So set can be represented in two ways. One is roster method, or it is also called as what? Tabular method. And one more is what? Rule method, or it is also called set builder method. In roster method, how you are writing? You are writing all the elements in a set. So in suppose for example, set A is a set of natural number less than or equal to 4, right? So all the elements you are writing separated by a comma. That is to be a roster method, is also called as what? Tabular method. We have one more method, that is rule method. The same set of natural number less than or equal to 4 can be represented in another way also, that is to be rule method or set builder method. In set builder method or rule method, you are giving the description about the elements which are present in the set. So I can write the same set as set A consisting of element x, such that x belongs to natural number and x is less than or equal to 4, I can write, right? So this is way writing a set in another method, that is rule method, or it is also called as what? Set builder method. These are the two ways of representing a set. And next you said about what are different types of set, right? So in first year, what are different types of set you said? That is, first is empty set or null set. As the name itself indicates, if a set consisting of no element, right, number of elements in the set equal to what? 0, that is to be empty set or null set. So either a symbol or it is a null set. We don't write the null set in this notation. This is a wrong representation of null set. Either empty set or this symbol null set, which represents that is your empty set. And non-empty set, what is non-empty set? A set which is consisting at least one element. If I take it, that is set of natural number less than or equal to 4, a set which is consisting of at least one element, that is said to be non-empty set. And singleton set, a set consisting of a single element. If I take only one element in the set, that is said to be singleton set. And next is what is finite set and infinite set. A set consisting of finite number of elements, that is finite set, and a set consisting of natural number less than or equal to 4, it is a finite set. And if I take one more set B, set of natural number, which is an infinite set, it is, that is finite set and infinite set. Next very important concept we said in first year, that is subset and superset of a set. So when do you say a particular set is subset of another set? So suppose A is a subset of B. When do you say A is subset of B? This is the notation for subset. If every element of A are present in B, then A is to be the subset of B. Or as A contains B, we can tell A contains B, right? And what is superset? If A is a subset of B, right? If A is subset of B, what is B? B is a superset of A. B is contained in A, can tell, right? So A is contained in B, or this is what B contains A. Can so B is a superset of A, and this is what A is to be subset of A. Every element of set A are present in B, then A is to be the subset of B. And what is proper subset, right? What is proper subset? A is subset of B, right? If A is subset of B, and A should not be equal to B, right? So we know that A is subset of itself also. A set is subset of itself. If I write a one set A with subset of B, but that subset should not be equal to B, then those type of subset are said to be the proper subset of a set A. And what is improper? A set which is not proper, right? Means A should be subset of B, and A should be equal to what? B. That is said to be improper subset. That indicates I can write only one set which is equal to the same set. So means you can write only one improper subset for a given set, any set capital A. And what is power set, right? So power set, suppose A is a set. What is the power set of A? Denoted by P of A, right? So P of A means power set of A. It is a set consisting of all the subset of the set A, right? So if I take all the subset of the set A in one bracket, that is said to be the power set of A, right? So power set of A is a set which is consisting of all the possible subset of a given set, capital A. And next, what is equal set and equivalent set? So when do you say two sets are equal? If they have same number of elements and same elements, or else if two set are said to be equal set if they have same elements. And when you say two set are equivalent set, there is a notation for equivalent. So two set are equal if they have same elements. Two set are said to be equivalent set if they have same number of elements. So if they have same number of elements, then we say those two set as equivalent set. And next, what is all the set into consideration, or which includes all the subset of a given set? So that is sort of the universal set denoted by capital U. So capital U is a universal set, is a set which take all the sets into consideration. So that is sort of the universal set. And two important note related to set, that is you all aware about what is the possible number of subset you can write. The total number of subset of a finite set containing n number of elements, right? Suppose a set n of a is equal to what? N elements it contains. So set A has n number of elements, then how many possible number of subset you can write? 2 power n. So total number of subset for a set A containing n number of elements is 2 raised to n. These many possible subset we can write for a set A. And second, the total number of proper subset or non-empty subset, right? So total number of proper subset and non-empty subset containing n number of elements is 2 raised to n minus 1, because 2 raised to n is total number of subset. So if you want proper subset, one set you have to remove which is improper, right? So 2 raised to n minus 1 gives proper subset, and if you want non-empty set, one set you have to remove which is an empty set. So 2 raised to n minus 1 gives total number of proper subset, or else you can tell if you want to speak in terms of non-empty set also 2 raised to n minus 1. So these are two formulas you have to remember. Next, we will learn about in set is what are the operations on set we can perform, right? So you all are aware about union of two set, intersection of two set, difference of two set, and complement of a two set. If A and B are any two set, and union of these two set is also a set denoted by A and B. So A and B is a set consisting of element x. What type of x it is? X belongs to A as well as, or x belongs to B, it is, right? That is x is present in either A or x present in B. Those elements you are writing on side, that is to be A union B. And if you see Venn diagram, so total the A union B part, this is your A, B, it is a universal set. So total either elements present in A or B, that is to be the A union B. And what are properties related to A union B? So A union B is equal to what? B union A, that is, it satisfies the commutative law. And A unions A union B union C is equal to A union B union C, that is your associative law. So set, that is union property satisfies associative law. And A union null set is equal to what? A. So when I taking union, which is a bigger set, I'm getting the output. So A is a bigger set here. Null is what? Nothing. That is A union null is equal to what? A. And A union A is equal to A. U union A is equal to what? U only. And what are, how we can perform intersection of two set. This is about union of two set and their property. Next, intersection. So if A and B are any two set, right, then the intersection of these two set is denoted by A intersection B. It is also set consisting of element X. What type of X elements is there? X is present in A as well as X is present in B. The common elements which are present in set A and B, those common elements you are selecting and you're writing one set, that is, it is the intersection A intersection B. So if you speak in terms of Venn diagram, the common part which is for both A and B, this is A, B is your universal set. So the common part which is both present in A as well as B, that is, it is the intersection part, right? Yes, good afternoon to all of you. And some of the properties related to intersection. So intersection also satisfies your commutative law. So A intersection B is same as B intersection A, and it also satisfies your associative law. A intersection B intersection C is equal to A intersection B intersection C. And null intersection A. What is null? Nothing. Nothing intersection some set A rating. Right? What is the common part rating? Null only. So when I'm taking intersection, which is the smallest set, I'm getting the output. But when I take the union, which is a bigger set, that I'm getting the output. So U intersection A is A. A intersection A is what? A. And it also satisfies your distributive law. Intersection is distributive over union, and union also distributive over intersection. So A intersection B union C is equal to what? A intersection B union A intersection C. And A union B intersection C equal to what? A union B intersection A union C. So distributive, it also satisfies the distributive law. And one more operation, that is difference of a set. So if A and B are any two set, then what is the difference of the set A minus B? So A minus B I can also write as what? Only A also, right? Only A, or it is A minus B. So A minus B is also set consisting of element X. What type of X it is? Right? So X belongs to A, right? Only B. Only B means what? Elements of B, but not elements of A. So A minus B minus B minus A is also set consisting of element X, such that X belongs to B and X does not belongs to B. Means only the elements of A but not elements of B. So those elements, if read, that is set here A minus B. And you all know aware about A minus B is not equal to B minus A. If you speak in terms of Venn diagram, right? So this is your set A and B is your universal set. So which part is set to be your A minus B? Only A but not B. That is your, this part is set to be your A minus B. B minus A means what? Only B. That is B but not A. So this region is set to be your A minus B, right? And this region is set to be your B minus A. So A minus B, only A, elements of A but not elements of B. B minus A, only B, elements of B but not elements of A. This is about difference of two set. Next is last operation is, that is what is complement of a set, right? So how we can perform the complement operation for a set. So suppose A is a set, right? Then what is the complement of set A is denoted by A dash, right? It is a set consisting of element X. What type of X element it is? X belongs to U and X does not belongs to A. That is elements of U but not elements of A. Means apart from A elements. So which are the elements are there apart from A? That is your A complement or A dash. So A dash you can define as what? U minus A. So in total universal set, which are the set you are minusing? The A set, right? So elements of U but not elements of A, that is your A dash. So if you speak in terms of Venn diagram, it's a set A, right? So it's your universal set. So this part is your A. So A dash means what? Apart from A. So the outside part will be your A dash. So A complement is what? Apart from A. B complement is what? Apart from B. So this region, outside region apart from A, is it your A dash. And some of the properties related to your complement of a set. So A union A dash equal to our universal. So A dash means what? Apart from A. A union apart from A, nothing is common. So it equal to our null set. And complement of a complement set equal to our A only. And null dash equal to our U. Right? That is universal set. Null means what? Nothing. Its complement will be everything. So U dash equal to our null, that is U means what? Everything. Its complement will be nothing, that is U dash equal to what? Null. Or as U dash you can also it is what? U minus U, because A dash, right? What is A dash? U minus A. U dash equal to what? U minus U, that is equal to what? Null set, right? And two important law, that is De Morgan's law we say, that is A union B whole dash, right? So A union B whole dash equal to A dash intersection B dash. So complement of union of two set is equal to intersection of their complements. A union B whole dash equal to A dash intersection B dash. And complement of A intersection, right? This is A intersection. A intersection B dash equal to A dash union B dash. So complement of intersection of two set is equal to union of their complements, right? So these are two important results. A union B whole dash equal to A dash intersection B dash. A intersection B whole dash equal to A dash union B dash, right? And one more, two set A and B are said to be disjoint. When do we say two sets are disjoint? If nothing is common between those two sets, that is to be, then we say those two sets as what? Disjoint set. That is A intersection B should be equal to what? Null set. That is card means the number of elements present in distinct elements contained in a finite set A is called its cardinal number. Right? It is called its cardinal number. And how do we denote for a cardinal number? N of A, right? So N of A means number of elements present in the set A. Right? Some of the result related to cardinal number of a set. You all are very much aware about that one. Many times we use that result. That is first one, N of A union B. N of A union B equal to what? N of A plus N of B minus N of A intersection B. And if you want to find B, right? And n of A union B, I can also write as n of A minus B plus n of B minus A plus n of A intersection B, right? And n of A, from here on n of A graph, n of Venn diagram, right? So what is n of A? N of A means what? A minus B plus intersection A intersection, so A minus intersection B. And n of A only, right? So n of A only is what? Only A, or you also call as what? A minus B. From here only you can write, so n of A minus B equal to what? N of A minus n of A intersection B. So n of A only is equal to what? N of A minus B, right? N of A only or n of A minus B is equal to what? N of A minus n of A intersection B. So these two are very important, A minus B and B minus A. What is A minus B? N of A minus n of A intersection B. And what is n of B minus A? N of B minus n of A intersection B. So A only and B only. And last is n of A union B union C. What is n of A union B union C? N of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Right, so I think based on this result, we discuss some example. Section B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Right, so this is about result related to cardinality of a cardinal number of a finite set. Right, next is what one note, that is where if n of A is equal to m, number of elements present in set A is m and number of elements present in set B is what? N. So what is the minimum number of elements are present in A and B is given by maximum of m comma n. So among these two set, which set has maximum number of elements, that is the minimum number of elements present in A union B. And what is maximum number of elements present in A union B? So what could be the maximum elements in present in A union B? To get maximum number of elements, we should take minimum common. So minimum common is what? 0. If I take, then maximum number of elements in A union B equal to what? M plus n. I should add those two number of set, that gives the maximum number of elements present in A union B. This about minimum number of elements present in A union B and maximum number of elements present in A union B. And what is minimum number of elements present in A intersection B? What is minimum number of elements present in A intersection B? So we can say how much minimum we can take on between A and B? 0, right? So minimum number of elements present in A intersection B equal to 0, and maximum number of elements present in A intersection B. So among these two set, which set has minimum number of element, that is the maximum number of common element, that is the maximum number of common elements I can take in A intersection B. So these two note are very important, that is minimum number of elements and maximum number of elements in about in your first chapter set. Next, in second year and even in first year also, you studied about relation. Just it was an introduction for a relation and how to find domain codomain range for a relation. But in second year, you said about what is relation and what are different types of relation. So to define a relation, I should define Cartesian product. So if A and B are any two set, right, the Cartesian product is denoted by A cross B, or as product of pair element where A belongs to A and B belongs to B. If A and B are any two set, Cartesian product of two set is by A cross B and is defined as it consists of an ordered pair A comma B, where A belongs to first set and B belongs to second set. And what is relation? It is subset, right? Subset of A cross B. If I take the subset of A cross B, that is said to be a relation, right? And you studied about what are different types of relation, that is. So definition, just I will recall for it. Already we discussed some example based on this chapter, but as of now it was according to the schedule as this chapter was this. So we have to once again we have to discuss about this chapter. Element A belongs to capital A, right? If A comma A belongs to R, that is said to be a reflexive relation. And one more thing, to define types of relation, that relation R should be defined from A to A only, right? It should be defined from A to A, not from A to B. So a relation R is defined on capital A, then only we can define the types of relation. So this is about reflexive relation. If A comma B belongs to R in your relation R, implies if B comma A also belongs to R, that is said to be a symmetric relation, right? And implies if A comma C also belongs to relation. And what is equivalence relation? Right? A relation R which satisfies reflexive, symmetric, and transitive, that is to be equivalence relation, right? So this is about types of relation. And some of the no, if capital A and capital B are two finite set such that n of A is equal to m and n of B equal to n, then what is total number of relations you can define from A to B? The number of relations from A to B is given by 2 raised to mn. So total number of relations from A to B, where A is consisting of m number of elements and B is consisting of n elements, is 2 raised to mn minus 1. Because you should remove one empty set and empty relation, no, that is 2 raised to mn gives total number of relation. If he is asking non-empty relation, minus 1, 2 raised to mn minus 1 gives your total number of non-empty relation. And the number of functions, how many number of functions you can define from A to B is your n raised to m. Second set note related to transitivity, which is very important. The transitivity also holds good in the case if, right, if AB belongs to R but BC does not belongs to R. So if A is a relation, so whenever the second ordered pair is not exist to compare, right? So whenever the second output is not x to compare, then we say that relation satisfies the transitive relation. So this was about just revision for what all you learned in set and relation and some of the results. So let us go for discussing some examples. So I think first example everyone can solve this question, that is if capital A, right? So if capital A is a finite set containing n elements, then total number of subset of capital A is, right? So number of subset, what is number of subset is given by number of subset. Total number of subset is given by 2 raised to n. If capital is a finite set containing n elements, the number of subset is 2 raised to n. Suppose you are asking number of number of non-empty subset, non-empty subset, non-empty subset. In that case, it will be 2 raised to minus 1. But it is asking, what is asking? Subset. Total number of subset is 2 raised to n. Right? This was a simple question for you. Next, we'll go for second question. So second question says each set XR union. So what he has given us here, union of R runs from 1 to 20 XR is equal to R, right? So if each element of S, what is S? Union of XR. So XR, if each element of S belongs to exactly 10 of the XRs and to exactly 4 of the YRs, then what is the value of N asking? Okay, each set XR contains how many? 5 elements. So each set XR contains how many? 5 elements. 5 into what is R runs from 1 to 20 na? X1 consists 5, X2 contains 5. Up to so on R is from 1 to 20, X1, X2, X2 up to so on X20. So 5 into 20 elements are there in XR is equal to S equal to next, right? So and each set YR consists how many elements? 2 elements. So 2 into how many set are there YR? R runs from 1 to n, y1, y2, y3, y4 up to so on yn. So each set consists of how many? 2 elements. So 2 into n number of set are there. Next, what is given? If each element of S, what is S? It is union of XR otherwise union of YR. If each element, so it is about 5 to the 10, it is 100 is equal to S equal to 2n. So 100 elements are there in S and 2n elements are there in S. So if each element of S belongs to exactly 10 of the XR. So each element, one element is present in 10 of the XR. 10 of the XR means what? A single element, if we take about, among these 100 elements, if I take a single element, that single element is present in 10 set of the XR. So one element if I take, that is present in X1, X2, X3 up to so on up to X10. 10 different set it is present, a single element. That can present from, that single element can present from X1 to X10 or X2 to X11 also. That single element is present in 10 of the XR. So I should divide by 10 here also, and to the exactly 4 of the YRs, divide by 4. So 0 0 can get cancelled. 10 is equal to, right? S equal to 2 ones are 2, 2 so it is n by 2. So it is n is equal to how much? 20 you are getting. So the value of n is equal to 20. So just you divide by 10 because, right, each element of S belongs to exactly 10 of the X are divided by 10 and 4 of the Y are divided by 4. Let us go for next question. One more simple question for you, that is two finite set have m and n elements. Two finite set have m and n elements. The number of subset of the first set, the number of subset of the first set is 112 more than that of the second set. The values of m and n are, right? So two set have m and n elements. So n of a is equal to what? M, and n of b is equal to what? N. The number of subset of the first set, what is total number of subset for first set? 2 raised to m. The number of subset of the first set is 112 more than that of the second set. So total number of subset in second set is 2 raised to n. number of subset in first set is 1 1 2 more than the number of subset in second set. So if I simplify this for the option wise, right? So when I take m is equal to 7 and n is equal to 4, it is 2 raised to 7 minus 2 raised to 4 is equal to what? 112. So the value of m and n should be what? 7 and 4. If you take the option wise, first option if you take, it will not satisfy the sequence. 2 raised to 4 is equal to 112. Second option is the correct one. So the value of m is equal to 7 and the value of n is equal to what? 4 it is, right? So we'll go for next question. So next question says, in a town of 840, right? So in a town of 840 persons, 450 persons read Hindi, 300 read English, and 200 reads both. Then the number of person who read neither. So neither means what? Neither A nor B. So either A or B means it is A and B, right? So either A or B means n of A and B, but it is neither A nor means what? N of A and B whole dash equal to question mark. So neither A nor B, that is your A and B whole dash. How to find A and B whole dash? How to find A and B whole dash? N of U minus N of A union B, right? So 840 persons, so that is your N of U. N of U is equal to what? 840. 450% read Hindi. Let us take this what? A. N of A 290 S, where N of B equal to 300 and 200 read both, that is N of A intersection B. A intersection B is equal to what? 200. We can find N of A and B now, right? What is N of A and B? N of A plus N of B minus N of A intersection is what? 550 it is, right? And N of A and B whole dash is N of U. What is N of U? 840. N of U minus N of A and what is N of A and B got as 550, right? So 840 minus 550 is what? 290, we can tell. That is your second option. I think it is easily, you can get the result with the help of Venn diagram. This is A, this is B. It's your universal set. What is common? Both intersection is how much it is? Intersection is 200, right? So here I let us 200. And what is N of A? 450. Already I written 200. 450 minus 200, it is what? 250. Together it becomes 450, right? What is B? 300. Already I written 200 here. So how much to write here? Only 100. So if you add all these three, it is 450 plus 100, it is 550. 550 minus 840, it gives 290. That is neither A nor B. It is the outside part, right? And suppose if you are asking only A, right? What is the total number of persons read only in the newspaper? That time it should be, it's your 250. That is your only A, and this your only B, and outside part is neither A nor B. That is your 290. Better. Next question. Next question says, if capital X, right? So capital X equal to 8 raised to n minus 7n minus 1, such that n belongs to natural number, and capital Y is equal to 49n minus 49, such that n, what is n? Set of natural number. Then what is it satisfy? Whether X is subset of Y or Y is subset of X, or X equal to Y or X intersection Y equal to null set. Okay, what is X? X is a set consist, what, how it is defined as X here? 8 raised to n minus 7n minus 1, such that n belongs to natural number, right? So if I finding the values of, if I substitute the value of n, and if I take the elements of x belongs to natural, n belongs to natural number. If I take n is equal to 1, right? So 8 power 1 is what? 8. 7 into 1, 7 minus 1 minus 8. 8 minus 8 equal to what? 0. First element I am getting as 0 in set X, and I put n equal to 1. Next, let us substitute n is equal to what? 2, right? 8 power 2, 8 square 64. 8 square 64. 7 2s are 14. Minus 14 minus 1 minus 15. 64 minus 15 is what? 49 I'm getting when I put n is equal to 2. Similarly, if I put n equal to 3, 8 power 3, right? What is 8 power 3? 512. 512 minus 7 3 is the 21. Minus 21 minus 1 minus 22. So 512 minus 22 you are getting as what? 490. Likewise, the elements will be getting, and I put go on changing your n values. These are the elements present in set X, where X is defined as 8 raised to n minus 7 n minus 1. Let us see what are the elements are present in Y, where Y is defined as what? 49n minus 49, such that n belongs to n it is, right? So if I take n is equal to, right, if I take n is equal to what? 1. 49 into 1 is what? 49 minus 49, 0. I'm getting as 0, and I put n equal to 1. And I put n equal to 2 into 49 minus 49. 2 times of 49 minus 1 times of 49, it is 49, right? And I put n equal to 3. 3 times of 49